Hi, welcome back to the channel. In this particular video, we're going to look at how to use discriminant to determine how many row solutions we have to a quadratic equation. And furthermore, we're going to look at how to determine the sums or sums of roots, product of roots of quadratic equations and some other expressions in terms of the roots of quadratic equations. So let's just get right started into the problems. Now, before we delve into the problems, notice that we need to understand what discriminant is. So for a general quadratic equation, which is ax squared plus bx plus c equal to 0, this is what we call the discriminant, right? So the discriminant is b squared minus 4ac. I think most of you would agree with me that you notice this expression you basically notice this expression in the root of a quadratic equation using the quadratic formula, which is this, right? B squared minus 4ac over 2a. And so this can be written as what, plus or minus square root of for discriminant over 2a. And now this is where the conditions on when we have real root, complex roots come from. This is where the condition comes from. It literally comes from this particular expression. Okay, so we're talking about discriminant, which is b squared minus 4ac. And we're going to use this to determine the number of roots in a quadratic equation. Now, what are the conditions? The first condition is if I get discriminant to be greater than 0, this implies I have two distinct real roots. So that means I will have two real roots and they'll be distinct. When I have the discriminant to be equal to 0, this means I have only one real root. So you have one root that is repeating itself twice, right? Repeat one real root repeating twice, right? Okay, and then the last part is when the discriminant is negative, then we no real roots. We don't have any real roots. In this case, we have two complex roots, and these roots, they'll be conjugate of each other. They'll be conjugate of each other. Okay, so these are the conditions. And how do we come about this condition? This literally comes from the solutions of the solutions of quadratic equation. So when you look at this quadratic equation, when you look at the root of this quadratic equation, the general formula, we have square root of this discriminant. Now notice that you understand that one of the conditions of a square root function to be able to be expressed, so for you to be able to have is a particular real number out of this square root, what it means is that the inside of this square root must be greater than or equal to 0. Okay, if the number inside the square root is negative, that's when you have complex, which is the case for this, right? So we notice that when determinant is negative, we have two complex roots, right? And both of them will be conjugate of each other because of plus or minus that we have in front of the square root. Okay, now when the discriminant is 0, this whole expression becomes 0. Therefore, all you have here is just minus b over 2a, or plus or minus 0, right? So this part goes away and you have minus b over a, which is just one number, which is why you have just one real root here. And the last case, when the inside is greater than 0, okay, what will happen is you would have square root of that number would be a positive number, okay? And because you now have plus or minus here, plus that positive number, so plus that positive number, this would allow you to have, now this will allow you to have, so let me just rewrite this. So in that case, you have plus or minus square root of this real number. And because of that positive number, and you have plus or minus here, that will allow you to have two different distinct in two different roots, which is two distinct real roots. Okay, so this is basically the conditions which determines how many real roots we have is tied with the value of the discriminant, and which is tied to the solution to the general equation of quadratic equations. Okay, so let's just get right into the problem and try to use these conditions to determine if each of these quadratic equations would have how many real roots they would have without actually finding the roots. So the first one is this. So we are in 1a. So we have x squared plus 2x plus 1 equal to 0. Now, what does this tell us? A is the quotient of x squared, A is 1, B is 2, and C is what? The constant, which is 1, okay? C is 1. So what is the discriminant here? Remember, it's B squared minus 4AC. So that would be 2 squared minus 4, A is 1, C is 1. So that is 4 minus 4 is 0. What does this mean? 1 real root. As simple as that. What about the B problem? The B says x squared minus 3x. B says x squared minus 3x minus 3 equal to 0. Now what happens here is A is 1, B is minus 3, and C is minus 3. So which means the discriminant will be minus 3 squared, B squared, minus 4, A, C. So that would be minus 3 squared is 9, minus 4 times 1 times minus 3, that will be plus 12, and this is 21. It's greater than 0, so you have 2 real roots. And finally, we have 2x squared minus 10x plus 20. So we have 2x squared minus 10x plus 20 equal to 0, of course. Okay. Now, how do we find this? This gives us what? The discriminants to be minus 10 squared minus 4ac. Okay. So which is 100 minus 4 times this is 8 is 8. 8 times 20 is 160. Right? We have minus 160, which is what? Minus 60. This is minus 60, which is negative. So no real, so this means no real roots. Now, as a bonus problem on this, let's say the question is not that direct. Let's say you are given this. Let's say this is the problem you're given and you're asked to find the number of roots here. So the first step is to make whatever you have to look in this form, all these forms, right? So the first thing that you do is you move all of them to one side. So you move everything to the left-hand side, right? And rearrange this way. So you move this to the side. Now, if you like, you can find the discriminant this way, or you can multiply through by 3 so that you only have integers as coefficients in this quadratic equation. Okay, so multiply through by 3. So when you do that, what happens is you're multiplying each term by 3. So what I mean is multiply everything by 3. So you multiply each term by 3. So this will give you minus 2x squared because 3 will cancel 3. Then minus 3 times 3, that's minus 9x, then plus 12 equal to 0. Now you can find the discriminant. Now the discriminant is minus b squared, which is minus 9 squared, minus 4a. Don't forget your a is minus 2. And your C is what? 12. So this is how you can solve such kind of problem. You have 81 plus 8 times 12. That's 96 plus 96. And of course, you know, this would be, this is 177. So this would be, this is a positive number. So which means that what you have 2 real roots. So another way to have solved this problem is you move everything to the other side instead of left-hand side, move everything to the right-hand side, and you have 2 over 3x squared plus 3x minus 4 equal to 0. Do the same thing again, multiply through by 3, and you would have this. And then when you find the discriminant again, you would have 9 squared minus 4 times 2 times 12, which would times minus 12 rather, which would give us 81 plus 96 again, right? Which means 2 real roots. So this is just a bonus problem for that. In case you are given an unusual expression, which is still quadratic, how you should manage it is to rewrite it in the standard form so that it becomes easier to find the discriminant. Okay, now let's move to the second part of the problem is, which is, okay, now we have this stuff. What will be the sum of the roots and some other expressions that we have? Okay, so let's deal with that here. Now let's come back again to the basics. So we know that the general form of quadratic equation is this, so this is not square. Okay, we have this, right? Now, what the rule says is when I have alpha and beta to be the roots of the above quadratic equation. Now, what happens is this. It happens that we can actually prove this, but this will leave for another video. If you guys really need the proof to this, make sure you comment down below, then I'll make a video on that. So what this says is alpha plus beta, when I know that alpha and beta are the roots of this, alpha plus beta should be what? Minus b over a, and alpha beta, when I multiply the roots, it should give me c over a. Now you have to be careful when how you apply this, and you have to memorize this formula. Right, there's no two ways about it. You have to know this. Extremely important. Okay. Now the b we're talking about is the coefficient of x, and the a is the coefficient of x squared. C is the constant term. We already know this. So let me just give you an example. A simple one. Let's test it. Let's verify if this thing is actually true before we use it to solve the problems that we have here. So we know that x squared. So let's say minus 5x plus 6 equal to 0. So let's look at this as an example. Now, we know the roots of this particular equation. We can factorize this into x minus 2, x minus 3 equal to 0. We can factorize this way, okay? Now, what happens next? We know that what? This would be x equal to 2 or x equal to 3. If you don't know how to solve this using factorization, make sure you check my previous video on quadratic equations, on 3 different methods of solving quadratic equations to get acquainted to how to solve such type of equations. Okay, now that we know the roots, what will be the sum of the roots? So what I'm basically saying is that this is alpha and this is beta because they are the roots of this quadratic equation. So what we're trying to, what we are saying here above is this alpha plus beta would be 2 plus 3, and that will be 5. And then alpha times beta should be 2 times 3, and that will be 6. Now let's verify with this formula. What does the formula say? It says alpha plus beta is what? Minus b over a. Now what is, so that means that we need to find a, b, c, right? Okay, good. What is a in this quadratic equation? A is 1, b is minus 5, and c is 6. Make sure you get this these variables up front, okay, before you evaluate alpha plus beta. So alpha plus beta would be what? The sum of the roots. Without actually solving the quadratic equation, you can know what the sum of the roots is, right? So how do you know? Alpha plus beta is minus b. What is b? Minus 5. All over a is 1. So this will give us minus times minus, that will be 5, which is exactly what we got here, right? Then alpha times beta is c over a. What is c? C is 6 over 1, which is 6, which is what we also got here. This is basically what the formula is saying, and it is true for any quadratic equation. Let's look at a complicated one before we look at the problems, right? So another example is this. Let's say I give you this. Let's say plus 4 equal to 0. We want to find the sums of the roots of this quadratic equation, so which is alpha plus beta. We said this is minus b over a. So don't forget to write the variables first. A is the coefficient of x squared, which is minus 2. B is the coefficient of x, which is minus 5, and C is the constant, which is 4. So this minus b is not the same thing as this minus. This is the mistake most students would make. They are not such students, so don't make that mistake. So we write the minus here. Then what is b? Minus 5. All over a is what? Minus 2. You can see there are so many minuses coming into play. This minus comes from the formula. This minus comes from b, and this minus comes from a. So when you evaluate it, this is just minus times minus is plus, divided by minus, that is minus again, right? So you have minus 5 over 2 as your answer. It means for this quadratic equation, when I add the roots together, I should have minus 5 over 2. And what about the product of roots? That would give me c over a. And what is c? 4 over a is minus 2, so that will give you minus 2 as well. So this is how to find the sums of roots and product of roots of a quadratic equation. Now let's go back to the problem that we solved and try to use this formula to evaluate them. Okay, so what was it? And then we try to evaluate all the other expressions as well. So we have x squared plus 2x plus 1. So the first one is this. So this problem 2, the first one is what? X squared plus 2x plus 1 equal to 0. Okay, so the sums of roots. So the first one that we need to find is alpha plus beta, which is b minus b over a, right? Don't forget. Second one is alpha times beta. Third one we're going to evaluate is alpha squared plus beta squared. And the fourth one we'll evaluate would be alpha cubed plus beta cubed. Okay. Now, alpha plus beta is, so let's find what A is 1, B is 2, and C is 1. So alpha plus beta is minus B over A, which is what? Minus B is 2 over A is 1. So the answer is minus 2 for this problem. What about alpha beta? This is C over A. So by the formula, this is C over A. What is C? C is 1 and A is 1. So you just have 1 as your answer here. Now, these ones are a little bit strange. Alpha squared plus beta squared. Now, what you have to note is we need to write alpha squared plus beta squared in terms of alpha plus beta as well as alpha times beta. So we note that when we do this expansion, alpha plus beta all squared, this will give us alpha squared plus beta squared minus 2 alpha beta. Okay, which tells us that what? Alpha squared plus beta squared can be written as what? Alpha plus beta all squared. Then we take this to the other side to make it 2 plus 2 alpha beta. So which means what we are looking for is alpha plus beta all squared plus 2 alpha beta. Now, what is alpha plus beta? We already got it as minus 2, right? So we bring that is minus 2 squared. Okay. Then plus 2 times alpha beta. What's alpha beta here is 1. So that will be 4 plus 2, which is 6. So this is how to evaluate alpha squared plus beta squared. This formula is very crucial, and you have to remember this formula. You have to know it offhand. Okay. Now, the last one is alpha cube plus beta cube. How do we get alpha cube plus beta cube? We do the expansion again of alpha plus beta raised to power 3. And this turns out to be alpha cube plus beta cube plus 3 alpha squared beta plus 3 beta square alpha. And when we factorize these terms, we end up having 3 alpha beta is common to the last 2 terms. What will be left will be alpha plus beta. So this is the factorization of this. After expanding this, right, we can factorize the last 2 terms into this. Okay, so what does this give us? This gives us alpha cube plus beta cube as what? Alpha plus beta all cube minus 3 alpha beta times alpha plus beta. What a beautiful formula. So you also have to remember this. Very, very important. Now, what is left? And we'll learn how to do such kind of expansion. This kind of expansion, we'll learn it very soon using binomial expansion or binomial theorem, okay, or Pascal's triangle. All right, so what is alpha plus beta? We already got it as what? Minus 2. So that will be minus 2 cubed. Then minus 3 times, what is alpha times beta? That is, we got it as 1 times alpha plus beta again times minus 2. So this will give us minus 2 raised to power 3 is minus 8. Minus 3 times minus 2, that is plus 6. So this will give us minus 2 as our answer for alpha cube plus beta cube. Okay, we'll use this result in the order in the remaining problems. Okay, so the second one is x cubed minus 3x minus 3. Okay, so let's come back. So the second quadratic equation is, so let me make this thicker. All right, so the second one is x cubed minus 3x minus 3 equal to 0. So your a is 1, b is minus 3, and c is minus 3. So what's the first thing? Alpha plus beta, which is minus b over a, and that is minus b is y minus 3 over a, there is 1, so this will give us 3. What about the second one? Alpha beta, which is c over a, and what is c? C is just minus 3 over a, which is 1, and this will give us minus 3. As easy as this. And the third one is alpha squared plus beta squared, and we already said this is the same thing as alpha plus beta squared minus 2 alpha beta. And what is alpha plus beta? That is 3 square minus 2 times alpha beta is minus 3. So when you simplify this, you have 9 plus 6, which is 15. That is alpha squared plus beta squared. Okay, if you have to pause the video to rewind to see how I did the previous one, or to kind of slow things down, you can do that, right? But I think it's quite clear and most of you will be able to follow directly. And finally, alpha cube plus beta cube. From our previous conversation, this is something as alpha plus beta all cube minus 3 alpha beta times alpha plus beta. So when we simplify this, what do we have? Alpha plus beta is already given as what? 3. So that means 3 cubed minus 3 times alpha beta, we got as minus 3. Then alpha plus beta again, we got as 3. So this will give us 27. 3 cubed is 27. Then minus times minus, that is plus 3 cubed again, plus 27. So you have 54 as your answer for alpha cube plus beta cube. Now let's move to the last problem. So let's move to the last problem. And what is that last problem? It says 2x squared minus 10x plus 20, right? I think that's what I have. 2x squared minus 10x plus 20. So the last part is, let's move. So let's move to this side. So the last part is, we have 2x squared minus nx plus 20 equal to 0. I hope that's really correct. Okay, yes, 2x squared minus 10x plus 20. Good. Now that we have this, if you like, you could actually divide through by 2 first, but we don't have to. So let's just do a is 2, b is minus 10, and c is what? 20. Now the first one is alpha plus beta, which is easy, which is just minus b over a, which is minus 10 over 2, which is 10 over 2, which is 5. Okay. And then the next one, alpha beta, which is just c over a. Please don't mix these two things up. Make sure you know this thing very well. Alpha plus beta is minus b over a, and alpha beta is c over a. Now c is what? 20, a is 2. Divide this, that will be 10. So that is alpha times beta, which is the product of the roots of this quadratic equation would be 10. Okay. What about the third one? Alpha squared plus beta squared. This is just alpha plus beta all squared minus 2 alpha beta. And what does this give us? Alpha plus beta is giving us 5. That is 5 squared minus 2 times 10, right? So that would be 25 minus 20. That is 5. That is alpha squared plus beta squared. And finally, we have alpha cube plus beta cube, which is alpha plus beta raised to power 3 minus 3 alpha beta times alpha plus beta. Now, alpha plus beta is given as 5, so 5 cubed minus 3 times alpha beta is 10, right? Times alpha plus beta again times 5. So 5 cubed is just 125, right? 25 times 5, that's 125. Then 3 times 10 is 30, 30 times 5 is 150. Right? I think that's correct. Okay, so this 125 minus 150, that's minus 25. So that is what? Alpha cube plus beta cube. And that gives us all the solutions to the problems that we have in this particular set. I hope you did enjoy this video. Make sure you subscribe to this channel if you feel like this content is very valuable to you. Share in your other social media channels so that other students like you would be able to find this channel and find it also valuable to them as well. And of course, like the video and comment down below if there's any content you would like to see in this particular channel. Don't forget to click the bell button so that anytime I upload a new video, you'll be the first to know about it. So that brings us to the end of this video, and I'll see you guys in the next one.